Hello guys, my name is Ian. I'm the author of the kitchen generator tool for Houdini engine for 3ds Max, and today I will show you how easily you can create kitchen layouts with the basic tools I will provide, and let's dive straight into it. So first thing we do when we use the kitchen generator, we draw a box, which is basically the size of our kitchen line or a linear kitchen, like how long or how wide the kitchen totally is in total, which means this can vary as much as you want. This is in meters right now, so 6 meters, or I don't know, 20 or whatever. Doesn't really matter. Let's make it 6 for start, or a bit less. Let's make it 5.8. So what it does, the script takes this box, measures it, and then calculates how many of the A elements, B elements, and the rest of the elements fit into it. If there is a remainder, it's gonna cut it a bit shorter depending on the size of the remainder. Basic elements, we have the A shell, which is your inner box of a single kitchen element, here displayed only as a box, as you can see, and the 3 different fronts. I have used materials so you can see the difference. I haven't modeled. This is just using the box so I can see if the script works and stuff like that. This is just my test geometry. B shell is 80 centimeters wide, which is usually where the sink is, and it has its corresponding front, which is 80 centimeters wide and I don't know, 2 or 3 centimeters thick. The rest of the geometry is sink, which follows the position of the B shell, stove, which follows the position of one of the A shells, the duct follows the stove as well, and the cabinets go on their own separate positions. So how it looks when we open the script. There we go. This is our first kitchen. Let's call it first kitchen. So as said, input box will change the size of the kitchen to as long or short we want it. So let's make it 5.8 as it was. There we go. So small breakdown. Here is our HDA kitchen generator. Here all of the controls, I will show you how they work. And here are the inputs. The first input is basically our box used for measuring. The next 4 inputs are A boxes, the next 2 are B boxes, and the rest are the sink, stove, duct, and cabinets. So let's dive right into it. So here we are. All of the upper parts, this is the element input, all of the different elements ranging from sink, from A elements, B elements, and the rest. All of the elements are being transformed. Material assignment, material ID assignment, and grouping and nulls for each of them, so I can use them later. The red part is the import of the measure box, which then generates a straight line through it, which is then used for element movement. The whole element movement logic is this. And then this whole thing is basically assigning different groups to different points to tell the script which element goes where. And the green part is basically just copy to points for different elements. This part on the side is bottom part and top part. They are fully procedural and automatic, and you can just modify them with sliders. The small part here is the randomization part of the A elements, which is basically using 3 different fronts for the A elements to get various randomization. And that's pretty much it. Here we are in 3ds Max. So what I did, first thing what I did, I drew a box, which is, as I said, our initial element that we're using to generate the whole kitchen. So basically you just wanna draw it to fit your scene, I guess. As you can see, this is my scene for now, and this is the camera, and so I drew a box this big. Next step, we have to load up the Houdini engine for Max. So first thing what we do, we start a session. There we go, success. We import our HDA, load asset here, and then we select the HDA and we press create modifier HDA on selected object. It's gonna make a modifier which you can later delete if you don't like it. So, made a modifier. Nothing is happening. First thing we do, we lock this to current selection. There we go. Now we are locked. Even if I select something else, this is gonna stay right here and I can just, it's much easier for selecting elements. I have modeled some basic objects just to test it out, to see if it works. Material assignment, how I did it, like for instance, if you have an object with different materials, with more materials, I have used this stack method for now. So material 1 is basically the whole thing, and then material 2 is the handle, as you can see, or material 4, sorry. And I have done this for all 3 of these, for this one as well. And for instance, if you have different metal parts on your sink or your faucet, etc., etc. Now, let's start using the HDA. So, you have several different inputs here. It says A shell. So I should input all of these first and see what happens. So this is my A shell. Let me select, click. It's gonna load right into. As you can see, it's named A shell and it matches, so that's good. This is A1 front, A2 front, A3 front. As you can see, stuff is starting to happen. There we go. All the A elements are now in. Now let's load up the B element. So this is B shell, B front, and now we're already getting a basic kitchen for now. So we can add sink as well, stove, duct, and cabinets. And now what we get is this horrendous looking kitchen. And this is because we don't have any bottom thickness or top thickness set. So since I've done this before, I'm gonna just put this to 8 centimeters bottom thickness, just to get a height from the ground. By the way, this is still hard coded, so I couldn't remove any of the additional zeros, which is a bit stupid, I know, but it is hard coded into the engine, so I can't really do much about it yet. I will update it once it gets fixed. So as I said, bottom thickness first, I gave it a bit of thickness. Bottom push, we want to go minus, which is inside. So I know these numbers already, so I'm gonna put it 4 centimeters. Yeah, there we go. This should be good. Or you can go more if you want, depending on your scene. So top thickness, same thing. Let's make it, I don't know, 4 centimeters. Yeah, that looks okay. And now let me just skip and just move everything up so I can see what's going on. So we have cabinet height. I'm gonna make it 80 centimeters. There we go, much better. Okay, we have a problem here. This is our sink and there is no hole for it, right? Since we haven't inputted anything yet. I think this top push for now is alright, so I'm not gonna touch it. And I'm gonna just pump up the top board just to get the backboard. So since I put this 80 centimeters, I'm gonna put top board 80 centimeters as well, so I can make it fit right to the cabinets. There we go, much better. So hole size X, hole size Y, which is basically our sink. So let's start for now just to get this line a bit like this, so it doesn't go all the way over the sink, just underneath it. And now let's do the Y one like so. But since you can see our sink is a bit offset from the hole, we can use the sink offset X, which is this, just to center it to the hole like this, or maybe like that. There we go, perfect. But the only problem is our sink is still too low. Since I told you we're using bounding boxes to calculate this, I have the slider for the sink offset, which can bring it back into the proper position. I think this position was like 31. Yeah. And since our pipe is going through the wall now, we have to offset it forward a bit. So we use this one to push it out just a bit, like that. And now our sink has a proper hole, and we can render it nicely, as you can see. It doesn't cut through any geometry. Perfect. Now what next? So this cabinet is really annoying. I don't like it like this. And my B position of the sink, I'm not really satisfied with it, because if I watch my shot here, I don't like it being here. So I'm just gonna offset it a bit. I don't know, let's go 2 places, maybe even more, like this. Okay, I like that. Let's add a bit of randomness to change the fronts a bit. This is nice. And I don't like these two being separated like this, so I'm just gonna cut them out like this. Perfect. And that's pretty much it. What you can do now is you can add a edit poly modifier to this, and then on top of that you can add a chamfer modifier, for instance. It's not gonna break, as you can see. It works nicely. Nothing's happening, nothing's broken yet, except the normals, they look off. So we have some of these issues which I can basically skip, just applying proper settings for the chamfer, which is using unsmoothed edges only, and then lowering this to like, I don't know, 0.15 maybe. This is not bad. And since the normals are still off, we have to put more segments, smooth chamfers only, smooth to adjacent, and we are ready to go. As you can see, we have a hole cut already for the oven, which you can just place inside. The sink is ready as well, the cabinets are ready as well, with all the chamfers working, and the duct as well. And now the only thing left to do is turn on the scene and see how it renders. So let's give it a try. Here we go, Corona render. As you can see, this renders out nicely, everything works, everything is fine. I mean, we don't have any direct issues or errors. Also, as you can see, the tool is pretty stable. I had no crashes yet. And I mean, you can even go back to the tool and change stuff around even while it's here we go. Even while it's rendering, for instance, I don't know, let's just change the randomness a bit. And this should all just update. I mean, it takes a bit, it's a bit of an overkill to do it like this while rendering, but as you can see, no crashes. I mean, we can add those boxes on top again, and I don't know, move the sink or whatever you want to do. As you can see, it works perfectly even while interactive rendering. Now let's try something else. Let's try some of our custom elements. So let me turn off the scene, and let me turn off the initial samples, and I'm just going to use the new ones, which are right here. Some of these were used in a video we made. So let's see how they work. First of all, I don't need this chamfer or editable poly. As you can see, this is still loaded in. I can go back to this and just replace the elements. So let's do just that. So this is our A shell. Yeah. A1, A2, A3, B shell, B front, sink, and stove for now I'm just gonna remove, and the duct as well. cabinets. I'm gonna replace them with this one. Sorry. There we go. And now what we do have is a completely different kitchen. Kind of completely different, but using different handles and a different sink. But as you can see, the hole doesn't fit, so we just have to rescale this a bit. So let's do that right away. So top hole size. I think it's 40 if I'm not mistaken. This is taking just a bit longer. Oh no, it's 40 something. Let's try 42. No. I just want it to fit perfectly to the edge. So it's 45. There we go. 45 here, 45 here, and this offset has to be turned off. Oh, sorry. This offset has to be turned off. There we go. Okay, we have to adjust this. So this is probably 40. There we go. Perfect. But this sink has chamfered edges, round edges. So let's do that. Top hole chamfer size. I think these were 1 centimeter big. Oh no, it's a bit less. There we go. No, then it's 3. There we go. 3 centimeters. Division 4. But as you can see, it needs a bit more. Well, a bit less. So I guess 28. Or maybe even less, 25. There we go. I like that. Okay. Nice round holes. Now all we have to do is just fit the sink in. And which is basically our sink offset Z. So what we can do is, there we go, fit it like this. And all we have to do is add another chamfer modifier to this. Now this is gonna take a bit because these things are being chamfered as well, so we can just skip that by using only smoothing groups and using only unsmoothed edges, which is basically all of our new elements generated, which is the top, the bottom, this back, and the sink hole. And we can put this to, I don't know, reasonable amount of 0.2, add more segments to it, and change the smoothing to make it look nice. And there we go, a completely different kitchen. Now let's try some, let's see what happens. Oh, sorry, yeah. So we have these holes now currently because I have hard coded it that usually above your stove you're gonna have a duct. So I left a hole there for cabinets not to fill, and also I did this for a sink. I could make this thing optional to be like a checkbox. Do you want an additional element over the sink or no? But for now it works. For most of the cases I think it works. And that's pretty much it. Now we can re-render this and get a completely different result. There we go. And this is pretty much it. That's everything you need to know about this generator. I can give you a bit more tips about how to make the shapes, like which dimensions to use. But so I'm gonna save these as well as a test scene, which you can then open and check out. These are the bounding boxes that you should be using for your elements. But for instance, if you're making another A element, you just have to use, I'm sorry, you just have to use this bounding box, but inside of the bounding box you can do whatever you want with it. For instance, I don't know, just add multiple of these, and I don't know, let see, ring, loop, and chamfer. Try like this, and open chamfer, so we delete the faces, we cap this, and this is our new A element. For instance, it can have multiple drawers. But you're not just limited on modeling this as a front. You can make this, since this will fit perfectly to your shell, like this. It's gonna leave a bit space on the right and on the left as well. What you can do, you can always model inside of this space as well. So for instance, if you want drawers to fit automatically inside, you can use this space as well. For instance, you can make a drawer like this. This is just a basic drawer, but you'll get the concept. So we cap this, and if I move this, for instance, to here or a bit up like that, and then I copy this a few more times like that. As long as these are part of the front, they're gonna work nicely. So you can just attach everything to it and then replace this front right here, and it should work. So let's try that straight away. So let's make this A2 front. So as you can see, it doesn't fit perfectly. The reason why I did this, since the whole script works basically on bounding boxes, this allows you to animate stuff and fill them a bit faster than it would take you to just push them all the way in and then detach them one by one. It will be much harder to select them, I think. So I just made them like this. So this way, when you collapse this, you can take, I don't know, these and then just push them in to the point they need to be, or you can, I don't know, just detach them and then animate them with a time frame. So for instance, I don't know, key, auto key, position, and then I don't know, in 16 frames it moves in. I think this was just a better ease of use than making them pop right into the place. But as I said, I'm open to suggestions. So if the community thinks it would be better to just make them fit automatically, sure. But if you're rendering closed drawers, you don't have to have the whole inside modeled anyway. So this was more like animator friendly version. This was much easier for me to use when animating things in video and my colleague. So this is why I left it like this. And that pretty much sums it up for the kitchen generator tutorial. Hope you guys like the tool, and I hope to hear some comments and critics, and I'm open to change stuff a bit if the usage proves to be better in a certain way than the way I made it. And that's pretty much it. So thank you for your time, and hope to hear from you guys soon.